Okay, and we will now continue with the next presenter. His name is Tomasz. He comes from Poland, and as you can already see from his title of the presentation, he's really hands-on and is a Linux user, which tells a lot already, as he claims. And he will be talking about the test environments management with Docker. So this is a constant problem for a lot of testers on preparing the test environments, preparing the test data, repeating the same tests so that the setup of the environment will be minimum. And we hope to find some great solutions from today's talk. So Tomasz, the floor is yours.
Hello, it's great to be here today, so thanks for the invitation, and let's start. I hope the slides will appear soon. Yeah, it's visible now. So that is environment management with Docker. I'll speak a bit about management of test environments. I'll speak a bit about Docker and how Docker can help during the today's case work. Maybe just a few words about me. I'm Tomasz Konieczny. I currently work as test architect and quality consultant, and I also quite often speak at conferences. In the past, I worked in very different quality, so test automation, test architecture. I also worked as a DevOps engineer, so I worked on infrastructure and introduction of DevOps methodology, etc., and a lot of other different things, not only related to quality. But let's start with the basic question: why do we even automate things? And because that's the conference for the testers and QAs, I think that the best example will be why do we automate regression tests? And the reason is that regression tests are quite repeatable. We have to repeat them again and again during the development process. And if we automate things that are repeatable, we can definitely save some time on this repetitive execution. The second thing is the better consistency. So if we run automated tests, they will always be run in the exactly same way. And that's really important in case of some development actions. So what about the automated test infrastructure? I often heard something like that's something for DevOps or admin. And that's quite wrong because DevOps methodology is working together as a team on things related to, for example, infrastructure. So the cooperation of different teams, so dev and operations. And to be honest, that's something that should be solved in other ways. But what about this test environments management? Well, if we think about it, historically, there were a lot of different problems related to management of application environments. So the configuration, I remember this was how to configure things, and not always it was working as expected. Repetitiveness. So every single developer had to repeat the same actions again and again during the development process on very different environments. And also consistency. So how to keep the environments consistent, how to make sure that it will work in the exactly same way and in different hardware configurations or on different operating systems. So the solution for that was to use virtual machines in the past. But there were also some problems related to performance. They were just really slow, and there were the compute resources that were required were really high. Let's start with a question: what is Docker? It's a tool for containerization and management of the containers. So what are these containers? I think that the best comparison is the comparison to the transportation and the containers that are used there as some form of standardized storage that they can be transported in a really easy way. And in software, the container is also the package, but for the application with all of its dependencies. So you can put anything that we need into the container, so the application, the dependencies, etc., and it will just work in the isolation. But why do we want to pack this application? Because it gives us a few benefits. So the first one is portability. The containers are standardized, so they can be moved in the exactly same way no matter what's inside. So that's really important. The second one is the isolation, because we can put anything into the container, so the application, the dependencies, etc., and it will just work. We don't need anything from the outside. Everything will be isolated inside the container. So we don't care what's the operating system, what's the hardware on top of that. We have our application, it's fully isolated. These applications have all of its dependencies, and it can just work there. The next one is standardization. So no matter where we will run this application inside the container, it will work in exactly the same way, no matter it's the development environment or it's the production. And also the lightness, because virtual machines were resource heavy. The containers are far more light. We can start them in milliseconds, and also we don't have the duplication of the guest system like in the case of virtual machines. So is it a container some kind of lightweight virtual machine? It's quite important to understand the differences here, because the approach and how we'll use these containers is completely different. In the case of virtual machines, we thought about virtualization from the system perspective. So we had the virtual machines simulated the whole computer. I mean, the hardware, the BIOS, everything on top of that, and we were able to install some operating system then there. And then on top of that, we were able to set up the application. And in the case of containers, everything is application based. So we don't need to virtualize the whole operating system. We just isolate the application or the process in the operating system. So it's way more simplified. The one additional thing that's really important here is the ease of use, because containers were available way before Docker. The thing that Docker introduced is that it's really easy to use it, especially for development purposes. It was just designed for this purpose. So let's start with some example. Let's finally run some container, so you will see how easy it can be to run something. And I thought about the example application I want to run, and I decided that I will start something that may be useful in case of development of some standard application. So if you don't know the tool named Adminer, it's just the web application that allows you to manage the MySQL databases in the easier way graphically. So let's start the Adminer. The Docker run command allows you to run any container based on that's available based on the example or available image. So let's run the container, Docker run -p, so that's port. So the application inside the container will work on the port 8080. And because we want to have it available on the host side, we'll just map this internal port into the host system. The name Adminer, so that's anything. That's the name of our container. We can put anything here. And the Adminer latest is the name of the image that will be. Speak a bit about images later. So let's run this command. You will see some image hash here. And let's run the next command, so docker ps -a. So that command prints prints all of the running containers. -a, that's all. So we can see that the container started 8 seconds ago. It was created based on the Adminer latest image. We can see also the port mapping, so port 8080 will be mapped to the port 8080 on the host side, and we can see that it started. So let's see what can we see on this 8080 port on the local host. Just a second. And we can see the Adminer application on the port 8080. So it's working as expected. But let's clarify what's this Docker image I used, because I mentioned I used some already available Docker image. So what's the Docker image? It's basically the description in the binary form how to create the container. So we can build some custom images. I will speak a bit about it later. But we can also use any of them that's already available, that are available in the Docker registry. And the Docker registry is basically the repository for Docker images. So we can pull any of the available images from the Docker registry and create container based on that. And the Docker will just know how to create the container based on image. But to be honest, the CLI interface will be rarely used in real projects. I mean, in most cases, we won't create the containers to a Docker run command. We will use infrastructure as code to make it more consistent with the development process. So we can put anything into our repository. We can describe the whole infrastructure part in the repository, and we can just create it easily. So let's see the different example. I will use the Docker Compose. And Docker Compose is the tool for container management. So we can manage the whole set of different containers that are needed in case of specific project. And let's see how it will look like in case of Docker Compose. On top, you can see the previous Docker run command, and below there is the Docker Compose YAML. So that's the file where which will contain the whole description of the infrastructure. For our case, it's just the single container named adminer again. So we can see the version, that's the API version of the Docker Compose that can be used. We shouldn't care much about it unless we need some very new features. And you can see the services keyword, so that's where we will define the containers. We can see the adminer here, and it will be created again based on image named adminer latest. And we also can see the port mapping, so port 8080 will be mapped to the port 8080 again. And we can put something like this into our repository along with application, and we can just run it with Docker Compose app. It will start the container. It will download the images, make everything that's needed, and just start the containers. So the Docker Compose is the tool for container orchestration. It's really important to understand this difference, because that's really important to know that every container is the single container should be used only for single purpose. So if you have the set of dependencies, like for example Apache, PHP, MySQL, or maybe Mailcatcher for testing purposes, every single container should contain only one of them. So that's really important if you want to work with containers properly, to separate every single dependency and work with them as the whole set. So if we have, for example, again, Apache, PHP, MySQL, Elasticsearch, Selenium, etc., every single one should be in separate containers. And why? Because then we can reuse images. And it's really important to be able to reuse something that's already available. We don't want to create the new custom image that will contain every single of these dependencies and then manage it, keep these dependencies updated. We want to reuse, so we can just download the image for example, a PHP or MySQL or anything else, and we can just reuse it. It's really important approach in the case of working with containers. So the next example, let's create the setup for the specific for the example application. I created a very simple PHP app that just prints this app text. So that's this index PHP file. And we can see the directory structure on the left side. So the index PHP, that's the only project file here. Let's create a Docker directory and let's put a Docker Compose YAML file inside. And you can see the Docker Compose YAML file on the right side. We need to create the container for the application, but let's assume that's something more complex and the application also sends some emails. And we want to use the Mailcatcher tool that will allow us to view them in the easier way instead of sending every single one. That's really useful for the testing purposes. So in this case, I used the PHP as the Apache module. So that's why it's a single image, but it's created by the PHP creators in the combination of Apache. That's something that we can later reuse, so that's fine. And in the services area, we can see two different containers. So the first one is app, that's the container for our application. And one is Mailcatcher that will catch our emails and allow us to view them. So let's start with the first container named app. We can see that the image PHP with Apache was used here. And we also have the port mappings. The additional 127.001 was added here. So it will be only mapped to the host instead of the whole local network. And we can also see the volumes keyword. So we want to mount it for development purposes instead of creating the production container that will contain every single dependency. So because of that, we can just map any directory on the host side, and it will be automatically updated on the container side. So we can use it during the development process. If we will edit anything on our host side in our favorite development environment, it will be automatically updated there inside the container. So that's why the volume was used here. And the second is the mail catcher. So I also used the standard already available image for the mail catcher, and I mapped the port so it's also available on the host side and also the local network, because this 127.0.1 wasn't used here. So let's start it. Docker Compose app again, and we can see that the additional network was created, the container named Docker app was started, and also the second one, so Docker mail catcher, was also started. And we can see our example application on the port 80 on the host side and our favorite browser. So it's working fine. Now, what are the advantages? The first one is that we have specific version of dependencies, because we have, for example, specific version of Apache or PHP. We don't have any changes on the host side, so it's really great. We don't need to adjust our operating system. Infrastructure as code, so we have everything in our repository. So that's really great. We can prepare these changes once and then just reuse it. So the configuration is one time. And also the consistency of environments, because every developer will create the local setup based on this specific configuration file. And that means every single developer will have exactly the same configuration. That's something that we want to achieve. And also very different environments. So we'll have exactly the same configuration of, for example, local environments as on production. And also it makes the management of environments really simple. From the QA's perspective, it means that we are able to test earlier in the development process, because we can set up the environments really easily, and it also means we can start testing earlier, because we won't waste time on setting up the environments. So if we have to change some dependency, we'll also have this consistency, because it's all about updating the specific image. So here we have the PHP with version 7.3.1. And if we want to update it to the different one, like 7.3.2, you can just edit this specific line, push the commit to the repository. So every single developer will have, or QA will have exactly the same configuration. And then we can just run the Docker Compose app. So that's really simple. Instead of trying to support a few different versions locally, that was needed in the past and it was quite complicated, we can just update the image that will be used, and we'll have exactly the same configuration in every environment after the specific version will be pulled. So even if the application requires very different versions of, for example, PHP, we can create a few different containers, and we'll have, for example, a PHP 7.3.2 or 7.4.1, etc., and maybe some node container. And we can manage it really easily, and we can have a lot of different versions at the same time. So it makes it simpler. But Docker is also reusability, as I mentioned it, and it's all about creating custom images. We can take anything that's already available, like, for example, container for PHP or container for Apache, and then we can build something custom on top of that. So it's all about creating Docker file. A Docker file is the description how to create the container. And it's all about creating layers on top of something that's already available. So, for example, we'll create the custom Docker file here based on the previous image that we used. So again, we will be using PHP with Apache, so PHP is a module here, and we'll use this container and adjust it for our purposes. So, for example, let's assume we also need the mod rewrite for Apache, and we want to also install Git inside the container, because maybe we'll be using it for the development purposes, and we want to download some dependencies in this way. So the run command allows us to run specific commands on top of the existing image and adjust it to our purposes. The copy command allows us to copy different files from the host side to the container. So it's mainly used for the production purposes to create the complete container with the application inside. But it's also possible to copy some dependencies from other containers. So here we will copy that dependency or the binary and USR bin directory from the composer image, and we will have it available inside our container after it will be started. So it really can make things simpler. And here we won't be able to use the already available image. We'll have to build the custom one. Let's see the Docker YAML. On the right side, we can see that the image keyword is not available here anymore. We have something like build. So we are telling Docker that Docker Compose that it will need to build something for us, and we just have to pass the context, so what's the main directory, and also where is the Docker file. So the Docker Compose will find this Docker file, will build everything that's needed on top of that, and will provide the image. Will create the container based on that. What's also really great that it's possible to define different stages. So that's the functionality named multi-stage build. We can take the base image as previously, like this PHP Apache image, and we can build named the target named, for example, appdev based on that. So that's the SM keyword. We can then pass the target, for example, if we'll be building up for the development purposes or for the testing purposes. We can build slightly different versions of images. So for example, for the appdev target, we'll have this mod rewrite, then we'll also install Git, Composer, etc. And then we can create the additional target named apptest. Let's assume that the testers will also use, for example, nano editor inside the container. We can reuse the previously defined appdev target, and we can create the next one based on that. We will only run this additional apt-get install nano command on top of that, and then in Docker Compose we can define the target, for example, app test. So the application for testing purpose, where we will have this additional nano editor that may be useful. So Docker Compose is also about building different layers. And let's see some example. We can define specific container sets that will be started. For example, we have the Docker Compose YAML file. That's the default one that will be used when we will run a Docker Compose command. But we can also pass any other Docker Compose file with the F keyword. So that's a custom file name. For example, we can pass it and run the Docker Compose test YAML file. So we have the same Docker Compose YAML that we had previously, but we'll also add something for testing purposes. So let's assume we are using Selenium. Let's start the container based on the image that's available, and also the Python container, because, for example, we will write the test in Python. We'll also map the volume here, so the test directory will be mapped here. And we can run it differently. For example, developers will only use Docker Compose YAM file, so that they can use Docker Compose app -f Docker Compose, and the QAs or testers can also use add the additional F parameter and the Docker Compose test YAM, so it will be just included, and the testers will have the additional containers running for them. It's also really important to remember that containers are stateless. That's by design. So unless we'll save data, we'll have some additional storage, we'll post the results somewhere. When we will close or shut down the container, the data will disappear. When we will start it again, created based on the base image again. So we will lose images that we had inside it. So that's why we need to use volumes to preserve data. That's the way to keep the data consistent or preserved between different container starts. And that's what's needed if we want to, for example, run the database inside. So that's the example with MySQL. We can see that we created the DB container here, image named MySQL. There are some default environment variables that are needed, and the last keyword, volume. So that's where we map the MySQL directory to the directory on the host side that we'll use to preserve the data between the restarts. It's also possible to use environment variables there. So we have this example on the right side. You can move them end file. And you can also have different end files to provide different values for different environments, for example. So you will use different ones locally, you will use different ones on the, for example, production servers. There's also something named detach mode that allow to run Docker in the background. So we can run it with -d parameter, and it will just start the containers on the background. So you want, if you want to do any other things, you can just do it in the same console. It's also really useful for some more like production purposes. And in the end, just a few useful comments that may be useful during the development that will be frequently used. So Docker compose up starts the container, creates them, down removes the containers, stops and removes. Start can start them after they were stopped, exec for executing any commands inside the container. You can also use it to connect to the specific container with the CLI, and also PS and logs for debugging purposes. Just a second. There's also something like restart policy, so you can define what should happen if you restart our operating system, if the container should start, or they should be just left without starting. And the last thing is that in the past I had to write really complex infrastructure manuals. But right now, when I'm using Docker, it's all about writing a few points like install Docker compose, some basic info about available targets, and also project-specific info. That's all. If you have the Docker installed, you can just run the containers, and that's all. And in the end, I want to just say one more thing. Technology can be really powerful, but it's all about using new tools and understanding different approaches, because this can really simplify things and make development more effective. And so DevOps is just the methodology. You have to be aware of that. It's all about cooperation, because DevOps is not a person. It's the part of the development process. That's how we have to work together to make something really usable. And that's all. Thanks. I hope you enjoyed that presentation. And if you have any questions, that's probably a time to answer some of them.
Thank you very much, Tomasz. We do have actually questions, and quite a few of them. So we'll start right off. So first question: what kind of tests are better Dockerized?
Could you repeat the question?
So what kind of tests are best, I guess, to Dockerize?
So I would say that anything that can be run locally can be Dockerized. I mean, I use Docker containers for some unit tests that were run inside the application containers. Used Docker for end-to-end tests, where I use, for example, Selenium or any other tools. So basically, everything that can be run headlessly, that's the only limitation. I mean, there are some applications that can be used with graphical user interface, but in general, most of the applications that will be run inside the containers are the command line applications. But it's also possible to run real browsers, like for example, X5FB. It's possible to create a virtual screen with X virtual frame buffer and run some real browser instance instead of the headless mode. So it's also possible. And basically, I'm using Docker for every single purpose locally. I don't want to install anything additional on the host side, because when I'm working with different teams or with different projects, it's a problem to keep up to date. It's just easier for me to create a Docker container. For example, recently I tried to set up the procs and the Selenium setup. It was just easier for me to start the containers instead of installing everything and then removing after I finished.
Thank you very much. And by the way, if someone has a follow-up question, like, feel free to right away, and we'll definitely get that question included as well. Moving to our next one. So can we generate the test data, sorry, environment for testing native apps using Docker?
It's I'm not sure what do you mean by native apps here, because it's a bit confusing. I mean that this word can be understood in very different ways.
So it was not specified here. Assumption could be it could be either desktop applications or native apps. It's a good question, by the way. If the person who is there in the audience who asked that can specify, and we can return to the question afterwards. Unless you, Thomas, have any thoughts on how to answer that.
Sure. Maybe if the person will specify the question, it will be easier.
Okay.
To answer it.
So let's move then to the next question. What if our app for many other applications?
Could you repeat?
So what if our application relies on many other applications?
Sure. So that's the same case that we would have normally without Docker, because if there are any dependencies, that then we can just connect to with them somehow. We can, if we are able to host every single of them locally, then we can just create the specific separate containers for these dependencies or other applications. Dependencies like some external providers or anything, we can just connect to them in the same way that we'll be able to do. So the basic role is to create the separate container for every specific application, or for this role a single container, single purpose. That's to everything and to the same container. But Docker can network communication of different containers, for example. So if we are using a tool like Docker Compose, we can manage the hosts, and we can create the container for everything that we need. Like, for example, a few applications that's quite standard case in the project currently, especially if we have, for example, some microservices one locally, everyone in a container, and they will just communicate.
Okay, we are losing Thomas for the. Let's just give a few moments to see if his connection will recover. Thomas, are you with us? There still seems to be some delay. Thomas, please confirm that you hear me. It's like attending a Zoom call. Do you hear me? Are you hearing me? Do you hear me now? So it seems that we have connection issues with Thomas. So what we will do from our side, we will post these questions to
Yes.
Thomas, and we'll ask to answer them separately, and we'll publish them with his slides. So it seems that we don't have him on the line anymore. Sorry about that. It happens. But nevertheless, thanks for Thomas for the talk. Hopefully you get some technical insight on Docker, and you can have more interest, and you can always reach out to Thomas as well. He will definitely appreciate it. Reach out, any feedback. Same way, please do rate these tracks, provide the feedback in our shared application. We really appreciate that to get to understanding of how our content was, and it's super useful feedback for our presenters as well at the same time. We will have a few minutes to go till our next presenter. So please, meanwhile, fill in your cups or water cups or whatever cups you have. Take a few minutes of break. Visit our partners of all. I can be overemphasizing again that we are super thankful to our partners. So visit the expo area. You can join. There are nice people to chat with you, participate with you in a session and you have. So yeah, and we'll be back in about 3-4 minutes.